Hello. How are things with you today? Whatever, whatever time of day it is for you. Hopefully it's going well. Uh, we're going to take some time today to talk a little bit about the content of chapter 2. And then I want to do some modeling. I want to show you kind of what a good way for you to set up for success in solving your programming problems. And I'll even model that in relation to an actual assignment. So without further ado, I usually kind of briefly go through the PowerPoints. I don't spend a lot of time on them unless like we're in some of the beginning stages, because I like to get to the fun stuff and show you the process of actually writing code instead of having you fall asleep looking at PowerPoints. So yeah. But today we'll see how far we can get before it's time to switch over to something a little bit more engaging than you know show the PowerPoint, fall asleep type time. So for this chapter, some of the content is, hey, how do we get started writing code? What are the parts of the code? What makes up what are the components of a C++ program? And what's a data type? And assignment statements. A lot of these different aspects of the language or any programming language that you will see. And of course, we're going to talk about variables and how those are dealt with, and we might get into a little bit on processing today and why we have to use special mechanisms of data types converting from one data type to the other. And I'll let you know a little secret. All data types are the same. They're all numbers. They're the same, but they're kind of not the same. They're all numbers, but they're different kinds of numbers. They're the numbers of different sizes. And the size really matters for when it gets loaded onto the CPU. And when the CPU actually processes two numbers that are represented in binary, they have to be the same size. So that means that they have to be the same data type. And there's a big old conversion for that, or the big old conversion. No, there's a system for making those conversions that is integrated into many languages. There's some languages where you don't even have to worry about it, like Python and stuff like that. They take that out of your hands. And get a little bit more into let's see, debugging is kind of let's add that to the list. I'm gonna show you how to debug and give you, because guys, I'm gonna tell you something here. If you learn how to debug, and I don't know why students, well, okay, I know why. I was one of the students that the last thing that I learned was how to debug, because it was too much for me. It just was. And especially when you're got all kinds of different classes you're taking, and but I'm telling you, if you learn how to debug, you can see it. You can see what's going on, and you're learning. I mean, the amount you will learn from working with the debugger to improve your code and your knowledge is extreme. It's so extreme, you will save yourself hours and hours and hours, days, years. Yeah, actually, yeah, years. So that's one thing I definitely want to show you. So let's get into it. What's a computer program? Well, it is something that was invented by a woman in the Army or Navy. I can't remember. I think it was Navy. Grace Hopper. You can look into her more. I'm not gonna really pull her up, but we had all these artillery automated artillery guns, and they were fitted with some really brand new technology, and they were trying to figure out how they could reprogram those guns without having somebody enter a whole bunch of ones and zeros. I mean, that's all that would happen is, when you're programming that computer, you're just throwing in ones and zeros, ones and zeros, ones and zeros. Um, uh, you're seriously, ones and zeros to try to program a machine? No, it doesn't work. Those instructions, sure, the machine can handle the instructions, it's built to handle them, but it's not something that really um, people are good at, especially with repetition, because a mistake would happen. But computers are really good with repetition. Humans, not. Uh, Computers, until lately, I would have said they're very stupid. But now that we have AI and they actually modeled AI based on the neurons in our own minds, um, it's kind of interesting to see that kind of take off. But yeah, computers are excellent at repetition. So Grace Hopper said, okay, well, why don't you build something where you could use human language, words, phrases that would then be converted into the ones and zeros machine language. And then that's how you could program those artillery guns much faster. And that's what we do now. From there, it started. So yeah, brilliant idea. All these guys running around programming these stupid guns and jogging from one to the next, spend 2 days programming it, missed the zero because we got tired and shit. Oh, excuse me. We have to restart uh, programming our 2 days over, reprogramming the artillery guns. And then this this gal comes along and points out how stupid they're being. It's just great. It's awesome. I want to be the fly on the wall for that kind of conversation and how that came about. But yeah. So a quick look at a C++ program. This is an example of kind of what one looks like. Now, this example is only showing the 2 steps of 3 main steps that you would have in a computer. And the 3 main steps, and I want you guys to, because you guys are going to be coming back to this. Because if you're ever kind of lost, you're out in limbo, and you're like, oh, damn, I have no idea where to begin. This is too complicated. I don't know what's going on. I'm feeling overwhelmed. Come back to these 3 steps. And for that, I'm going to get my chicken scratches out. And yeah, I'm left-handed, guys. I call them, my handwriting is chicken scratches. You know. But actually, you know what? I can actually just throw some text in here. Why are you being stupid? Okay, there we go. All right, there we go. Let's throw in some text. So the steps would be, and we're going to come back to this, input, and then I'm going to make some space, process, and then I'm going to make some space, and output. Okay, now what is that? Let's see. Those are the steps that we're going to be using to complete a program. So we're gonna come back to this. If you break down the programming scenario or the job into these 3 steps, that's gonna give you some breathing space. It's gonna give you a starting point. And once things get started in programming, they kind of snowball and they go pretty fast. Copy paste becomes very useful and so forth. So this one has process. Now the process is where it's actually doing some mathematics, where it's actually taking a variable and multiplying it. You see this star down here, right here. Perimeter is equal to 2 times length plus width. The plus, the multiplication, that's processing. So anytime you're taking numerical values on the computer and everything's a number, even your screen that you're looking at right now to watch this video. Those pixels are given a location, they're given a red, blue, green value, and then they're rendered on your screen with whatever your resolution your screen has. It's done very fast. And we have that process. Now we talked about main. Here's main. We talked about the return 0. Here is right here. This is called a brace. I call them squiggly things, curlies, but the true name is a brace. You have an opening brace and a closing brace, and this is the scope of your program. We also call this function scope because main is a function. It just happens to be the first function that runs when your program is executed. So you have variables that can exist in the scope of main or the function scope. And then we can also put variables outside here at file scope. And when I say scope, I'm talking about where variables are accessible within the logic of your program. So where are they at? Where are they located? And you can put variables inside of namespaces, inside of functions, inside of multiple files. You can have one variable be for all functions at file scope. There's a lot to unpack there, and I'm not going to delve into it because we're just beginning, and scope is probably the most, it's going to be the understanding that you're going to be developing as you progress. So these right here are variable declarations. Cout is output using the IO stream. This is a preprocessor directive, and basically we're saying we want that code inside of IOStream. Cout is created in IOStream, and then we can just use it like a tool in a toolbox. And so you can think of a preprocessor directive as a toolbox. It's a toolbox where somebody has built tools for you. And you open up that toolbox by including it and using the namespace to grab your tool out, and then you use your tool like cout. And what cout is just a tool to take information and render it to the screen in the console. Okay. So we kind of talked about this already. These are doubles, and these are what I also call these definitions, declarations. They and these are also called automatic variables or autos, because when your program starts up, it's given RAM from the operating system that it gets to use. And that RAM is given to your process. And that's called your stack. That's your stack. And the RAM that is given to your process, where your process is the only process that's allowed to access that RAM until, of course, the computer reboots and whatnot, because that RAM can be used by other processes when yours is not using it. You can then use that RAM to define or declare variables. And we call them autos because they are automatically placed on the stack. It's memory you don't have to ask for. It's memory that's automatically given to your process just to declare and use. Very simple, easy way of using it. You don't have to interact with it other than to say, hey, I want this variable. And that variable automatically goes on the stack. And that's what we call a declaration or an auto. Right here, this is an assignment statement. It's using a previously declared variable and assigning it to the value 6.0. Now, the double data type is a data type that's about 8 bytes, and it has a fairly large range of numbers that it can store, and it's a floating point number. And that's when we get into, hey, what are the different types of numbers we can have? We can have numbers that are whole numbers, 1, 2, 3. We can have floating point numbers, 4.0, 4.5, 6.0. We can have those numbers as hex, as oct, all kinds of different ways of representing that number under different number systems. And right here is where we have our output. So, and of course, process, length times width equals area, and then we output our answers. So this is a good example of process output. There is no input here, and that's possible. It just, programs don't all have to have input. They can just be process and then output. But then you get to thinking, oh, splitting hairs. What are they processing? So this particular input is just kind of automatically entered as like width equals 4.0. And you can do that with variables, so you can just process and output, of course. Okay. So when that memory goes on the stack and you assign it, you're going to be assigning the bytes that's used in your RAM on the stack to represent length is going to be modified to the bytes that show that its value is 6.0. And it's going to be the amount of bytes that a double has, and that means that it's 8 bytes. Other data types have different sizes. We'll get more into that and as we progress. Okay, semantics rules. Okay, so you're writing code. There is, when you're working with writing code, when the words syntax and semantics are used, you can think of it as syntax. Syntax is what you write. It's the code that you write. Semantics are how you write it. So there are logic errors where if you were to process this number before another number, you know, it wouldn't, the algorithm wouldn't work. So there's an order of, you know, in any algorithm of what you do first and then next. You know, hey, you guys have had algebra and whatnot, you know, that's kind of the way it is. So syntax is what you write, semantics is how you write it. Okay, then we get into comments. A lot of times when you're writing code, you're going to want to comment out some code for testing. You can do the 2 forward slashes in front of a line. You can do the multi-line comment where you do a backslash star or asterisk and asterisk backslash, and then anything in between those is a comment. And then you have different operators. Now the operators that you're mostly going to be using as you start out are the processing operators, the multiplication, times, minus, divide. Those are all operators. Well, operands. I'm telling you wrong. I'm using the word operators. No, they're operands. They're the operations that will happen. And it looks like we're using the term symbols from the PowerPoint here. I'm glad they kept me on track. This is just, you know, the operands that are available to perform operations on operators, numbers. You can determine whether a number is less than or equal to another number. It's not equal to another number. It is equal to a number. So these are all comparison operators. These are language specific, or operands, comparison operands, processing operators, or operands. I keep doing it. And then right here you got the semicolon, which is the end of an expression or the end of a statement for a line of code. Okay, now data types. What data types do we have? Int, float, double, char. Those are the different data types that are what I like to call primitive data types. And you'll be using those consistently. Some of these other things like void, const, return, those are for other aspects, but these are the data types. And of course, you'll be learning about these as we progress. So when we use the term identifier, we're talking about it could be a number, it could be a function, but it's basically a name that you're giving to something. Now, for an example of that is float, double, char. Those are identifiers. Pre-built identifiers. And yeah, identifiers is kind of a strong term for those. But when we give a variable name for something using these data types, C++ is case sensitive, guys. So you have to, when you define a variable or you're working with a predefined identifier like a cout operation or a cn, and these are just functions that output to the console. And then there's other things that are in the language that are reserved, specific words that you cannot use, keywords that are part of the language. Cout is a keyword. Cn is a keyword. I would not recommend creating a variable called cn. You don't want to do that. So things have to be protected with how we identify them. That goes with functions and variables. All right. So, how should we name things? Well, we've got some rules. Spaces are a delimiter. And we can have a numerical value in an identifier, like this one down here, second, but it has to be at the end. It can be ND2, that would work, but it cannot, the number cannot be in front of something you give a name to, because then the compiler can't decide on whether you're just putting a 2 in for the literal number 2 when you're trying to assign it to a variable, or you're actually trying to create an identifier or a variable. Now, operators, operands, operators like plus, those can't be in a name. Hello, the exclamation mark, it cannot be in a name because that is used as a logical operator. So what we do is we would put those two words together, employee salary without the space. Maybe use camelback so that the second one is uppercase. Hello, we just, take out the exclamation, 1 plus 2, put the plus in there. Second, we just say second. You could do second with the 2 behind it after the D. That's legal. That's fine. The compiler can determine that you put a character first, therefore it's not a literal number that you're trying to use for some kind of assignment statement or whatever. It knows that it's a variable name. So a lot of what you're dealing with is based on white space characters. White space is used to separate out everything when your compiler goes to read your code and compile it into an executable. And of course, we use white space naturally to separate out words like every, space, C++. White space we use all the time for delimitation. Okay, now let's get into data types. We have data types that are primitive, simple data types. Those are data types that are just like numbers, just simple numbers that are in different formats. Like, characters is a number because we actually use numbers to assign a value to the keyboard characters. Like the letter D is actually assigned a number on a computer. It's not a D, D is actually assigned a number. And that's called the ASCII character code. ASCII, ASCII character code. In fact, let's look that one up because it's that important. ASCII is pretty much what you're using to write the code. It's the lowest level of all computers in the world, including the ones in China. China then adds to it with their own characters, which we call Unicode. But ASCII code characters is what every computer has. And if you do an ASCII code search, the table that I like is this one right here. I've always used this. Okay, I didn't want a big old web page for that. I just wanted the image. Thank you. All right. So we can see here that the capital A is assigned the value 65, and its hexadecimal value, the hex of 65 is 41. The oct of 65 is 101. The HTML code of 65 is A. Don't get stuck up on that stupid stuff. Just the decimal value is fine enough. Capital A is 65. Done. So we have char characters, chars, char, that we assign values, character values to, but they are actually numbers. But we treat them like characters, so that there's a layer of abstraction. And notice that even numerical values are assigned a number. Yeah, numbers are assigned numbers. Boom. Yeah. Numbers assign numbers. Okay. Yeah, we're having entirely too much fun this morning. Let's see, where are we at? So simple data types, numerical values, primitive values, I also call them that. Integers, which is whole numbers, 1, 2, 3. Floating point numbers, 2.3, 3.4. Structured data type is where we put multiple simple data types into a box and label the box. So a structured data type contains multiple numbers in it. And in it, we've boxed them up, and we got to go through that wrapper that we give a name to use the data types inside of it. And that's why we call them structured, because we structure them in boxes, essentially. They're also called structs. Now, pointers are a very powerful thing, and it's also one of the things that people struggle with the most, is understanding pointers and their use. But a pointer, what it does is it holds the address of memory that's in RAM. That memory can be on the stack, or the memory can be on the heap. Now remember, the stack is memory that's given directly to your application to use. The heap is all the other memory that's available in RAM. So pointers can point or reference numbers on either the RAM, the stack in the RAM, or the heap in the RAM, which, you know, heap is kind of a word meaning just all the other stuff out there. The heap of RAM out there, you know, kind of like the garbage heap or whatever, you know. All right, floating point numbers, integrals, we kind of talked about this a little bit. Enumerations are important. They're just kind of lists of values that are pre-assigned in a sequence to flag certain things. You know, variables that you define that you want to flag with pre-specified values. So don't go down the rabbit hole too much on enumerations. In upper level languages, they are important to kind of understand, like Java, C#, even in C++ in some ways. But anything else is, you know, like chars, which is the character that we just talked about. A short is basically a 2-byte integer. An integer is 4 bytes. That means it can go from 0 to 32,000 or something like that. A long is like an 8-byte integer, maybe. It might be bigger than that. Yeah, well, no, but all of these variables, bool is just a true or false. It's a 0 or a 1. Unsigned versus signed. That means that we can either use a bit in the bytes of that number to represent whether it's -1 or just 1. If we use that bit for just positive numbers, then we can get some extra storage out of that variable. And so an unsigned int can go from 0 to 65,000. Or no, 0 to an unsigned int, yeah, can go from 0 to 65,000 roughly. But a signed integer goes from -32,000 to +32,000. So that range is now been taken and put over so that you can have values that are unsigned and signed. All right, so here's some examples of integers. Looks like 2 to the 31, 4 bytes. Oh, I was talking about a short int when I said 32,000. Excuse me, guys. Yeah, that's a 2-byte integer. That's negative 32,000 to positive 32,000. So a 4-byte integer is larger. It has quite a bit larger value or range of values that it can store. Now you see a long can store a huge amount of numbers, and this is just the how large the number can get in either the positive or the negative direction. So a long is 64 bytes. And if you were doing things like web crawling Google, your Google web crawler, you would be using these variables to keep track of how many websites you've crawled or characters you've read, stuff like that. Anything where you need to keep track of large numbers, you would use the appropriate data type for that. Okay, you do not need to require the plus sign when you're assigning integer values. Just leave it out. You do need to put a negative sign. And these are what I call literals, because you literally type them into the source, your source code. Now Boolean, they say it's true and false, but guys, what it actually is it's 1 and 0. False is 0, true is 1. But they've abstracted it from the use of 1 and 0 because it gets confusing, and it's easier to know that you're working with a bool if you use true and false instead of 1 or 0. It's just to kind of make it nicer to work with. Easier to look at some code and get a better idea of what it does and what it's for. Okay, we have characters, chars. We talked about that in the ASCII code. Even a blank space is a character. That's in our ASCII, it's in the ASCII code. You'll see white space as a character. Okay, so I showed you the sequence of 120 ASCII code set. Now, scientific notation, I'm going to glance over this because, guys, I don't want to, we're in 40 minutes here, and I wanted to do some modeling. So we talked about, kind of the basics that we needed to for variables, except for, here is kind of an important thing. You guys all know how to multiply, times, and divide. You should know order of operations. That's called operator precedence and associativity, but that's something for next chapter anyways. This is what I wanted to get into. And then we're gonna go play. I'm going to do a lightning run through the rest of the stuff, but there is, when you're working with multiple numbers, and let's say that you're trying to take an integer called A, and add it to a double called B. And I always hit this stupid button that messes this thing up. Okay, you're trying to add it to, and this, let's say that this is a double. A double is a very large 8-byte. It's the size of 8 bytes. This is an integer. It's only 4 bytes. So before you can add these two together, because let's talk about why. On the CPU, because the CPU, your processor, that's what we call it, the processor, is what does the processing. And on it, it has areas where it loads the variables on. And this is a very crude sketch, But let's say that each of these little boxes that I'm drawing, each of these little boxes is going to be where a 1 and the 0 for A goes, which is an integer. And I'm going to be very crude and not totally correct on how this is done, because a lot of this stuff is really abstracted out away from us. So we just need to have kind of a rough understanding. And this is where we load B. And that's so that the processor can do the plus operation. It's the CPU that does the processing. Here's the problem. A is 4 bytes. So A gets put in, and let's say that it's like, and I'm going to be using the very simplistic, this isn't correct, but let's say it's 4 bytes, so therefore it only takes up 4 spaces on the CPU to load up on the CPU for a plus operation. B gets loaded on, and it takes up 8 spaces because it's 8 bytes. Okay, now the CPU cannot handle this. Why? Because what does it add here? Because it's a mechanical thing. Since these variables have different sizes, when they're loaded upon the CPU, it doesn't compute literally because of the mechanical nature of the CPU. So that means that you cannot add an integer to a double. You can't subtract it. You can't do any processing between different data types because of that limitation. And guys, this is for every programming language out there. So a lot of languages will automatically graduate the integer to 8 bytes for you. That's called an implicit conversion. Sometimes the compiler will yell at you and say, oh, these need to be converted properly. And then you have to do an explicit conversion. So this is where we get in to have some fun. It's time to get in some code, guys. Really, because this is fitting to be more than an hour already. And I know, if you haven't, pause it, take a break, come back later. In fact, I'm going to pause real quick. We'll come back and we're going to start writing. When I come back, we're going to start writing some code, and then we're going to lightning fast go through, well, maybe not lightning fast, but we're going to finish up the PowerPoints. All right, let's go write some code. And then we'll continue on. And I've still got a model, a program for you. Let's begin by opening our folder that we did or that you may have started. Now we can open up our project here one of 2 ways. We can double click on the SLN or the VC proj, one or the other. I'm going to start up our program that we built. Come on. It's going to take forever. Visual Studio sucks. Oh my goodness. I'm going to pause it, and I'm not going to make you guys go through this nightmare. I will bear it alone. Well, finally, we get that up. Okay, I'm going to go to the Solution Explorer. Source files. There's my file. Okay, here's an example of how we do a convert. Integer j equals 0. double D equals 3.0. Okay, now double answer equals 0. Now let's change this J. Yeah, right there. Okay. Now, when I am taking and I am taking and I am saying that I want a double as an answer. I want it to find what D plus J is. Okay, so what we're doing here is we're D is a double and J is an integer. We're adding them together, we're processing. So that's a problem. So something has to happen. And usually what the compiler will do is it will do what's called an implicit conversion for you. It'll know that you are trying to get a double answer, so therefore it should take J, and if we just graduate J to a double, it makes it 8.0, and we don't lose any data with that conversion. And so what it'll do is it will implicitly graduate without you even knowing behind the scenes that J to a double, then it'll add it to D, and then you'll get your double answer. However, if you're taking an integer, I answer, and you're assigning it to the same thing, and let's make this a little bit different. J plus D here. So now the compiler is like, oh, you're trying to assign, well, let's do our using namespace std. The actual safe way to do it in the proper way is to do it this way. To open up the door just for where you need it, so that you don't have too many variables clashing when you open up the whole IOStream namespace or the whole standard namespace. But that's okay. So this is doing it this way. This is not production level code. Production level code would be if you do it safely down below, like I showed you. However, we do not start teaching students that way. I just want to make a note of that, just so, because students don't really understand namespace yet. So we just open it up, especially when you're being trained or taught. So here's the problem. D is 3.5, it's a double. We're adding it to J, which is 8. And you're like, oh, well, that's easy. Why is that a problem? That's 11.5. Well, the CPU can't physically compute it. The terms "it does not compute" is literal there. So what ends up having to happen is that the behind the scenes, when you're compiling it, it may attempt to do an implicit conversion, or it may just give you an error on that and saying unable to implicitly convert because of the loss of data that's going to happen. Oh, it looks like I'm going to have to make some fixing here. Yeah. Yeah, I had to open it up in my other one. It got confused on what version I was using for Visual Studio. But I just compiled it and, you know, build, rebuild, and you'll see it compiled down below. And what it does is it compiles it, and then you see right here, we get a warning. Now, warning is not an error, but it's just telling us that you're asking me to implicitly convert a double to an int. The double is D here. Since we're assigning it to an int, it has to be converted to an int. The problem is when you convert a double to an int, this 3.5 becomes a 3.0 or a 3. If it was 4.56, it would become a 4. If it was 8.94, it would become an 8. So what happens is when you do a conversion from a double to an int, you're losing all of that data that's in the decimal point. It truncates it and makes it nothing. So this is a big problem when you're working with some more advanced processing with mixed data types. You're going to get weird output, guys. You'll find like you'll be getting like a 0, and you'll be like, why the hell am I getting a 0? What's going on wrong? What am I doing? What, this is exactly what it's supposed to be. I typed it in exactly. I'm getting a, why a 0? Well, that's because it just puked that out because you're doing a mixed process. Something died there within the implicit conversions. And so then what needs to happen is for it to not be a 0 or come out, just puked out or whatever, you need to make sure that you explicitly cast it down, that you make the explicit conversion. Now, the old way of doing that is just to say in front of the variable you want converted, you just put in parentheses the variable you want it to convert to. So what will happen is before J is added to D, it'll downgrade D to an integer explicitly. This is the old school way of doing it. This is the proper C++ way of doing it. And if you're doing production level code, this is the way you should do it. You're going to see me cheating and putting in the old school way. You're going to see me doing it. I'm going to do it, but I'm just telling you right now that it's wrong. It's wrong, and I shouldn't be doing it, but yeah, whatever. Okay. In an int, yeah. That's how we do the conversion explicitly with new school. That's proper C++. The new C++ 11 is actually pretty cool. We've got some really slick additions. But that's a main key component that you're going to need to understand, because you're going to get results that you don't expect, and the reason why is because some kind of weird implicit conversion behind the scenes happened. And so then you have to go through your code and do explicit conversions and maybe look at the logic and the direction of the flow of how you're doing those processes and make a change based on what's needed there. Okay. Let's roll through some more PowerPoint, see if there's anything I'm forgetting before we get into our modeling. Here are some examples of static cast. I'm going to let you guys cover constant. What is this stuff? No, you're good. Make sure you review what a string is as well. We might actually go into that. That's probably one thing we need to talk about. Pre-increment, post-increment, I'm going to leave up to you guys. These are important because this is like some formatting And this is one thing that a lot of students don't understand, is that you can inject new lines into your output. Like here, if we output answer, and then I put in a \n, and this is a literal string, hello, \n, world, it's going to inject a new line into that output. And so when it runs, it'll say hello with a space, or with a new line. Hello, new line world. So those are pre-formatters is what we call them. And here's another thing is, since the formatters, you notice how it uses a backslash. So if we want to print a backslash, we can't do this. We can't just put a backslash in there because it's used as a formatter. So if we want to print a backslash, we have to use 2 backslashes. And basically we're telling the compiler, no, I really mean print a backslash. Because those backslashes are used for formatting. And we call this an escape sequence. And here's the interesting thing is, because a lot of what we do out in the real world is create programs that write programs, code that writes code. These escape sequences are very important to get a grasp of, and why they behave the way that they do. Because as soon as you're trying to write code and put backslashes into the code that you're writing, that writes code, so you're writing the code that writes the code, those escape sequences are very necessary. So that's how actually backend web servers are, like PHP. That's how WordPress works, and in the back end, is it's just a program that prints a program. It's a program that prints HTML right out to the screen through what we call standard output, which is what outputting to the console is. So take note of those. Maybe play with them a little bit, do a little research. And we talked about including our toolbox. There, string. Include string. Okay, if we want to use a sequence of characters, we call that a string. There's 2 different sequences of characters. There is the new string object, or there is what's called a C-string array. Now, we're not even covering arrays yet, so we're not going to get into C-strings. But it's actually what's inside of the string object. The string object was just made to be a little bit easier to work with than an array of characters. Even though what's inside of the string object is an array of characters, but often you'll see that where the older tech or the older stuff is built on top of with newer, easier to work with tech. But a string is, if you want to declare a string value, string name, you can use these double quotes as we call that a string literal, John. John, was assigned the string name. And you can actually go into name and use the dot operator, and you can do certain things with those string objects. Break them apart, grab pieces of the string out, like if we just want the O and H, stuff like that. So that's how we create a string and work with it, initially. And you're going to be working with it simplified like this until the chapter of strings comes along, and then we'll be doing a deep dive into it. All right, anything else? Let's see. All right, guys, we're getting too long in the tooth here on the timing. This is all stuff that you can read about. We've talked about most of it. See out, yeah, you can do that. All right. I want to model creating a program for you using the input process output technique. And for that, we're gonna talk to Sandra. Sandra is my best buddy. I talk to Sandra all the time. She's awesome. And do you know how many problems you can solve with her? She's great. Sandra is my chat GPT. Yeah, I love it. I love ChatGPT. Okay. Create several programming problems using C++ that have one input, a process, and an output for the difficulty of most chapter 2 introduction books. I have no idea what's going to happen, but I always like to find out. Chapter 2 style. Sandra, you are cool. You're using style. Double the number. Input a number, double it, and print the result. That one's perfect. Boy, Sandra's got some good imagination. Let's do double a number. I think that's at a level that's good enough for you guys oh no. Now let's go a little more advanced. I mean, let's do an inches to centimeters conversion. That one's perfect, actually. That's better than the other one. Okay. So, what is the input? Well, let me get my little scribbler out here. The input is going to be inches. Okay, there's my scribbler. That's horrible. Inches. Oh my god, I'm done with this. Control Z is my best friend. Control Z is my best friend. Control Z. Okay, yeah, let's just the hell with it. Let's just do it this way. I'll scribble on it later. Okay, my input is inches. Okay, you can do this in chart layout. You can lay it out however you want, simply or, but basically just put down what the input's supposed to be. And then what's the process? Well, how do I convert inches to centimeters? Well, let's ask Sandra. Sandra says that 1 inch is equal to 2.54 centimeters. Okay, so let's look at that. So then how would I process an inch? How would I modify that inch? Wouldn't we just multiply it by 2.54? Yeah, that's very simple. Okay, let's go back to that. Let's say here, centimeters is equal to inches times 2.54. And then what is my output? Now, also guys, this is very simplistic. I'm being very simplistic. Your IPO charts, input output process charts, when you really get into some heavy duty code writing, will be a little bit more mature, I guess. Whatever. Okay, well, duh. The output is centimeters. Okay, centimeters. Okay, this is a good way to start. we start with inches. I should have just done it this way in the first place instead of doing all those silly scribbles. Okay, we input inches, we process centimeters, we know what our process is, we know what our output is. Okay, now let's translate that into the program. Now for a program, I am going to take and I'm going to decide on my data types first. Should we allow floating point values here, or should we require that inches, it can be a fraction. It can be a floating point number, like 1.4 inches. I'm going to go with, let's keep the most resolution we can and go with it being a floating point. Now I'm going to use a different data type that's not a double. It's called a float. A float is a double. It's just half of a double. It's a 4-byte double number. And we call those floats. That's a 4-byte floating point number. That's what it is. But it only takes up 4 bytes instead of double taking up 8 bytes. So it's more efficient. So you'll see this out in the wild quite a bit. And I'm going to call this inches. Okay, so that's another thing that you can actually lay out in your IPO chart. That's something that can be added there. So we know our input is inches. Why don't we start with laying out our data types? And maybe I'm doing a CN. It's not sin, guys. It's not sin. I cannot tell you how much that's annoying. It's CN, C input. Okay. So you can, make use of the data, this input, process, output chart in whatever manner you want to organize your thoughts and on the place that you would get started to solve the problems. And so, yes, it can get more complex than this. You might even ask, oh, let's do that. Let's ask ChatGPT. Oh, yes. Give me an example of what an input, process, output chart would look like for a mid-level C++ problem. Let's just see what happens. Okay. Okay. I like this. Yeah. This is better than what I can do. Just showing you. This is awesome. Look at that. Oh, yes. I love you, chat. Okay, so here it is. This is for kind of an advanced problem. This says, hey, write a program that takes a list of numbers from the user. The user ends with -1. So that means we'd be using a control structure like a loop. And then it lays out exactly what the input would be, and then the different steps in plain English of how they would solve the problem. Then an output example, what does the output look like? Okay, give me an example of a low-level program. Okay, so this would be something that's a little bit more low-level, like what we just did. Oh, no. You're not supposed to do it for me. Oh, damn it. I meant give me the IPO chart for it. Sandra can be silly sometimes. She drives me nuts. Okay, so here's kind of an example. And then you notice that here. Now, incidentally, now this is a fun one, guys, because this one is where you are going to have an implicit conversion mistake. It's going to happen. So you know what I would do is I would put 32.0, 5.0, and 9.0 there. Because when you do a 5 divided by 9, that's a floating point number. So we don't want mixes. This is a clear example of where we want to take our process and modify it so that we can not have those implicit conversions happen. I would make C a floating point number, F would be a floating point number, and I would take this literal, and instead of 32, I would make it a 32.0, so there's no implicit conversion issues. A lot of students have a problem doing this because they will get weird answers like 0 all the time, and that's just because of how they're doing it, the order of operations, and 32.0, 5.0, 9.0, and not even being aware of those inappropriate conversions. Okay, give me a chart example of a high level program. Oh, file IO, dynamic data. Okay. So this is just some examples that I wanted to take you through, because here's where I get most of beginning students where they're mostly having the biggest problem is just getting started. That's the biggest problem. So break it down to little pieces. Do one piece at a time. Okay. Or here's a good way that you might, I would recommend not getting into Sandra too much, because Sandra's not always going to be there to help you. So I mean, because you could put the programming problem, give it to Sandra and have Sandra give you the IPO chart, and then solve it like that. Yeah. And I would actually be okay with that. But also challenge yourself, guys. If you can do it on your own without ChatGPT, that's where your confidence is going to be built. Because I'll tell you what, I've written a lot of code with ChatGPT, and I love the code I was able to come up with. And there are parts of it I don't care to understand because it's stupid detailed garbage stuff. It's stuff that I don't want to put into my brain because it's detail. Why? I want to be on a higher level, abstract, looking down, solving the complex problems from the details. So, okay, here's that. I think I think we're done, guys. Not too bad. An hour and 14 minutes. Oh, we didn't write the code yet. Here I'm thinking we're done. No. Okay, so let's write the code. Float inches, float centimeters. And then let's output. What are we going to output? We're going to output centimeters. Oh, you stupid thing. Okay, and it's going to be an answer. So I'm going to say centimeters. I'm probably spelling centimeters wrong. I don't care. And then right here, we're going to output centimeters. So it's also kind of, it's kind of nice to sometimes get your output in, get your variable and your output so you know where you're headed, and then fill in the processing in the middle. Yeah. Well, what's the processing? It's, oh, we got to ask the user input, cout, enter inches, and then we're going to do a cin, not cint, of inches. And then we're going to do the conversion. Okay, once we get our input, here's where I want to tell students to take things slow. And I always say to students, get your data, print your data. Just start there. Get your data, print your data. So I'm just going to print inches here. Make sure that I'm getting it as input. And I'm going to run it. Oh, I'm writing Python. I'm going to do that, guys. I got 7 languages always in my mind. Okay, Control S is my friend. Save it. Okay. Oh, build arrows. Maybe I've got, what does it say is wrong? Oh, I forgot. We got to do debugging too. So we're not out of the woods yet. Debug. That's next. Okay, it says uninitialized centimeters used. Oh, well, duh. Let's just comment that out for now. Get your memory, print your memory. Okay, let's say 4.5 inches. And there's my 4.5. Okay, got my memory. Now what are we going to do with it? We're going to assign centimeters equal to inches times 2.54. Then we're going to output the centimeters. And let's put a new line here. Let's inject a new line here so that it does a space after we enter inches and then output centimeters on its own line. Okay. All right, inches, centimeters. Okay. Debugging. All right. Here's what debugging is. What it does is it slows down the execution of your program so you can see what's going on line by line. And to do that, we set a breakpoint over here. We click and you see that little red dot there? We just click there and that's setting a breakpoint. And it's got to be done on some kind of code that runs, that does something. Like this isn't, we don't set a breakpoint here. We set a breakpoint here. And then what it'll do is the program will pause on that line and it will not execute that line because we may want to examine things around, variables around that line of code. And then we'll do we can click a button, step over, and it'll go to the next line. And we can see what happened as a result from the previous line of code. Oh yeah, see right there, it didn't stop here because this isn't code that actually does stuff. It's just definition code. So it's got to be on, you set a breakpoint on code that actually does something. I mean like some kind of action. So right here, we're saying enter inches. Now one thing that I can do here is I can look down here, and you see right here it says autos, and you see right here centimeters, inches. It's got crap value in it because we haven't assigned it anything yet. We can also right click on this and say add watch, and it'll track specific variables that we want to look at. We can look at the auto variables within that scope, or any of the locals. Autos and locals are pretty much the same thing. So we can actually track these variables. Now I'm going to do a step over, and now we're on this line. We can look and it output that. Now I can't do anything yet because we got to run the cin before we can put values in it. So now I'm going to do a step over here. Step over. It's right up here. It's got the arrow that kind of swooshes over. It'll say step over. It's also, I think, F11. I'm not for sure on that. Step over there. Okay. Now it ran line 13, cin inches. So now I can enter those inches. 45. Now I'm going to hit enter, and it's going to go down to the next line. And we see here inches has 45 in it. So this is what I'm saying about debugging. Why keep yourself in the dark when you can see it? I mean, you can literally see it, guys. You can see it. This is the way you should be running your programs. All of them. Put them in the debugger. Look at what it does. Look at its mechanical behavior from top down. Everything always works from top down, left to right. Okay. I'm going to step over. This line runs. And we got centimeters here at 114.3. I'm going to hit play to finish up, and we get our output. Okay. Now here's another rule that I want to go and I want to leave you with before we call it a day. And this is one of the more important aspects of programming. Everything works top down. I cannot move that up here, because the compiler has no knowledge of what centimeters is. Centimeters has to be defined before I can use that. I have to have the include IOStream up here so that I can use cout down below. So everything always happens above and needs to be defined before you can use it. So this guy can't go down to here or whatever because centimeters is above. It's not been defined yet. So we call this top-down programming. Now other programming languages, and even this one to some degree, kind of try to abstract that from you, because it can be kind of confusing when you're learning to program, that everything comes first from top down, left to right. And those rules of expressions, operator, precedence, and associativity. It's the same thing for every language. It doesn't matter. Doesn't matter what language. But this is, for example, C. but this is the rules that that left to right is following. Top down, they follow it naturally. But if we need to make a decision on what's evaluated first, left or right, that's all based on operator precedence and associativity. Now, this is what you learned in grade school. What do you do first, plus or divide? So the operators or the symbols that have the highest precedence that will be, happen first within a line, one line of code, and you have multiple symbols in that line of code, what symbol is dealt with first? What if you have multiple multiplications, multiple minuses? This is what we're going to be getting into. Should be doing it soon. Be talking about it more. So, make yourself a little familiar with this, and I'm gonna logical expressions. Yeah, one last thing. Okay, let's just get a little bit more into what I'm talking about. Inches, what if I did this? Plus 2 minus 2 divided by 5. Okay, so remember, rule is top down. That we don't have to worry about operator precedence and associativity. Now it's when we're on a single line of code that where operator precedence and associativity comes in. And it's left to right dominant. That means that we know from grade school that we got to do times and divide first. But which do we do first, the times or the divide? And that's where the left to right associativity comes in. That means that we're going to evaluate it from left to right, starting with the highest precedence, from left to right. Then it'll do this one. Then it'll do the final one. So inches times 254 will be given a value. Negative 2 divided by 5 will be given another value. Oh no, it's just 2 divided by 5, excuse me. Will be given another value. Then what will happen first? Oh, a plus 2 will happen first. Then a minus v will happen. And then the last bit. And that's how things are evaluated. And that's operator precedence and associativity. So there's different operators that behave differently based on that chart. So just remember to come back to that, because we're going to be talking about logical operators, some other things. Also this modulus operator, guys. This modulus operator is a programmer's best friend. Ask ChatGPT how the modulus operator is used and kind of the different ways it's used in computer science. Sandra will give you the down low on the modulus operator. Yeah, use her for stuff like that. Ask her why the operator precedence and associativity is important in programming. Guys, an hour and a half is enough. But you won't have any, the other videos that I'll probably post here will be short. So we pretty much hit everything that I wanted to accomplish. So you guys, hey, have a good one. We'll see you on the next time. Okay, bye.